The rest of the homework in 1.4 is instantaneous rate of change. Instantaneous rate of change really is not any different than the average rate of change. It's just the slope of the line connecting 2 points. But in this case, the 2 point is really just 1 point because we make the second point the same as the first point by doing a limit as h goes to 0. So for problem 18, it wants me to find the instantaneous rate of change, which is the same thing as the derivative. This is going to be a big deal to just get used to hearing these words that are interchangeable. Instantaneous rate of change. Can never spell that. Is interchangeable with the word derivative. And I'll sneak a new word in here. Interchangeable with the word tangent. Sorry, my dad called me back. Apparently didn't get to say everything he needed to say. So let me find the instantaneous rate of change. To find the instantaneous rate of change to a function, which is the same as finding the derivative of the function at that value, I need 2 points. The first point, its x coordinate's going to be the given x coordinate of 4. The second point, its x coordinate's going to be that 4 with h added to it. So for each x, I need to get a y. My first y, I'm going to get by going f of 4, which is going to be 4 squared minus 5, which is 16 minus 5, which is 11. So my first point to find the instantaneous rate of change at x equal to 4, or the value of the derivative at x equal to 4, is the point 411. For the second point, I'm going to do f of 4 plus h, which is going to be 4 plus h squared minus 5. I'm going to work on this 4 plus h squared first. I'm going to write it as 4 plus h times 4 plus h. And FOIL. Firsts are 4 times 4, which is 16. Outers are 4 times h, which is plus 4h. Inners are 4 times h, which is plus 4h. Lasts are h times h, which is h squared. And I still have the minus 5. I'm going to write this in a nice order and combine like terms. I'm going to write the h squared first. I'm going to add the 4h and get 8h. And I'm going to go 16 minus 5 and get 11. So the y coordinate of my second point is h squared plus 8h minus 11. The instantaneous rate of change is simply the slope of the line that connects these 2 points. I'm going to subtract the y's in the numerator. I don't have to subtract the x's in the denominator because the 4's are going to cancel. I can just write h in the denominator. So instantaneous rate of change, or the derivative, when x equal to 4, is the limit as h goes to 0, form a fraction, and in the numerator put the y coordinates, the y coordinate of h squared plus 8h plus 11. Here I wrote minus, but I needed to write plus 11. Minus that y, which is 11. And then instead of writing 4 plus h minus 4 and canceling out the 4's, I'm just going to write h in the denominator. The 11's cancel. I'm going to factor out an h from the numerator and get the derivative, or the instantaneous rate of change, when x equals to 4 is h times h plus 8 over h. I'm going to cancel. I forgot to write the word limit. That's an important word to write. It's the limit as h goes to 0 of this fraction. So that's going to be 0 plus 8. Once I plug 0 in for h, that's when I'm allowed to stop writing the word limit. And the answer to question 18, the value of the derivative when x equal to 4 is 8, or the instantaneous rate of change when x equal to 4 is 8. And I went ahead and sketched a graph to show you what this means. So at the point 411, I'm drawing a line that has a slope of 8. So I started at the point 411, went up 8 over 1, got to another point and made a line. This line right here is called a tangent line. When you start with a single point on the graph and you use the value of the derivative at that point, or the instantaneous rate of change at that point, this is called a tangent line. So I started with the point that I initially got without the h, found the instantaneous rate of change, which is the value of the derivative, which is the slope of a tangent line, went up 8 over 1 and drew another point. And that's visually what I found in problem 18. Let's move on to 19. So in 19, same thing. I want to find the instantaneous rate of change for the function 5 minus x squared when x equals to negative 1. How do I do that? I need 2 points. The first point has an x coordinate of negative 1. I'll figure out what its y coordinate is. The second point has an x coordinate of negative 1 plus h. I'll figure out what its y coordinate is. First point, it's y. I'll be lazy here and get cheap on my notation. Its y is 5 minus negative 1 squared. Negative 1 squared is positive 1, so that's 5 minus positive 1, which is 4. For the next one, it's 5 minus negative 1 plus h squared. That's 5 minus, and let me do this off to the side. Negative 1 plus h squared is negative 1 plus h times negative 1 plus h. I'm going to go first are negative 1 times negative 1, which is positive 1. Outers are negative 1 times h, which is negative 1h. Inners are h times negative 1, which is negative 1h. Lasts are h times h, which is h squared. This comes out to be h squared minus 2h plus 1. So I need to subtract, in a parentheses, h squared minus 2h plus 1 to get my y coordinate of my second point. So the y coordinate of my second point is going to be 5 minus h squared plus 2h minus 1. The 5 minus 1 gives me a 4. The second point, its y is negative h squared plus 2h plus 4. So all these computations are to get the y coordinates of the points, because in order to find an instantaneous rate of change at a value of x, or the derivative of a value of x, or the slope of the tangent line at a value of x, I need a full x and y for 2 points. So now, the instantaneous rate of change, the value of the derivative when x equals 1, or the measure of the slope of the tangent line when x equals to negative 1, is the limit as h goes to 0, and in the numerator I subtract the y. So it's negative h squared plus 2h plus 4 minus 4, and then just over h. I don't need to do any work in the denominator. It always simplifies to be h. The 4's in the numerator cancel. I can factor out an h and get f prime of negative 1 is the limit as h goes to 0. I'm just going to factor out an h and not a negative h. I get h times negative h plus 2 over h. Now I can cancel these h's and get f prime of negative 1 equals the limit as h goes to 0 of negative h plus 2. Fraction is gone. Now I can plug in 0. This is going to be negative 0 plus 2, and that's just going to be 2. My answer to question 20, the instantaneous rate of change when x equals to negative 1 is 2, or the derivative of the function when x equals to negative 1 is 2, or the slope of the tangent line is 2. Let me show you this visually. I'm going to plot the point negative 1, 4 on the graph of this parabola and draw a line that has a slope of 2, meaning I'll go up 2 and over 1. So I start by graphing the function 5 minus x squared. I plot the point negative 1, 4, and then I use the instantaneous rate of change. I go up 2 and over 1 and draw another point. This right here, this is now called a tangent line as opposed to a secant line. It goes the direction of the curve is going at that point, and its slope is positive 2. Don't have to do the graphs. There's enough work doing just the grungy algebra. An uglier one. Let's do an uglier one. And then we'll do one word problem. So find the instantaneous rate of change to this function when t is negative 3. I need 2 points. My first point is going to be negative 3 comma some value. My second point is going to be negative 3 plus h comma some value. Let me get the first y by going negative 3 squared. I should write g of negative 3 equals, but it's hardly necessary because I just want the right-hand side. It's negative 3 squared minus 5 times negative 3 plus 1. This is 9 minus 15 plus 1. If I haven't made a mistake, this is negative 5. Now I'm going to do the ugly one and change each of those t's to negative 3 plus h. I need to do negative 3 plus h squared minus 5 times negative 3 plus h plus 1. Do the exponent first. That's negative 3 plus h times negative 3 plus h. Negative 3 times negative 3 is the first, which is positive 9. Outers, negative 3 times h, negative 3h. Inners, h times negative 3, negative 3h. Last, h times h plus h squared. So this parentheses comes out to be h squared minus 6h plus 9. Now I'm going to tack on this and I'm going to simplify this. I'm going to go negative 5 times negative 3 is positive 15. Negative 5 times positive h is negative 5h. And I'm going to bring down the plus 1. I'm trying to make sure I don't have a mistake because I kind of feel like I might have a mistake here. But boy, it's not jumping out at me if I do have one. My theory is sound. Maybe my algebra here isn't sound, and you don't want bad algebra, but I'm just worried that I'm not matching up this 5. And let me pull out another sheet of paper before I go further and make sure that I have this right. I have negative 3 plus h squared minus 5 times negative 3 plus h plus 1. I feel like my y is off. It might not be off, but it's not what I'm expecting it to be. And sometimes when I make a mistake, I can never find it. And I make the same mistake like 6 times in a row. Yeah, this is what it is. I think that is the y for the second point. I kind of got the same thing twice here. Here I'm going to combine the minus 6h and minus 5h and get minus 11h. And 9 plus 15 is 24 plus 1 is 25. It disturbs me that that number isn't matching up, but hey, maybe it's not supposed to match up. I'm used to more what we do in the next section than what we're doing here. Here, this is kind of a specialized case rather than the general case. So there's my 2 points, fingers crossed that they're correct. And now I'm going to try to find the slope of the tangent line by taking g prime, the derivative, or the instantaneous rate of change when x is negative 3, is the limit as h goes to 0 of y2, h squared minus 11h plus 25 minus y1, which is negative 5, and then just over h. This double negative is going to turn positive. I have a mistake. I just don't know what it is. But I have a mistake. It must be on the y-coordinate of this point. Let me try. Oh, yeah, there it is. Oh, now I see it. So here, when I was doing this y-coordinate, I said -5 times -3. I wrote -15. I should have put +15. And I should have did 9 plus 15 plus 1. The y-coordinate of my first point should have been 25. I knew I had a mistake because I knew these numbers needed to match. And they weren't matching. The reason they weren't matching wasn't the hard algebra, it was the easy algebra that I punted on. So this should be -25 as opposed to minus -5. So there's where my mistake was. The constants have to cancel. If the constants don't cancel, you have a mistake. That's why I went to this next sheet. I said, oh my gosh, these constants aren't going to cancel. They need to match up. I need to match those numbers up. They didn't. So this is good to know to be looking for that. When you get your points and you do the subtraction in the numerator, everything that doesn't have an h should cancel. So the 25s now are going to cancel. And now I'm able to factor out an h. And now I can cancel the h's and get the limit as h goes to 0 of h minus 11. Now I can plug in 0 and get 0 minus 11. The answer to 22 is going to be g prime of 3, the instantaneous rate of change when x is equal to 3 as -11, or the derivative of the function when x is equal to 3 as -11, or the slope of the tangent line to the graph when x is -3 as -11. Let me show you graphically what's going on here. Here's a picture of t squared minus 5t plus 1. That's a parabola. I correctly plot at the point -325, and then I'm going to draw a line that has a slope of -11, which means I go down 11 and over 1 and draw the line. This right here is my tangent line. It connects the graph at one single point. It has a slope of -11. So one last problem. You're not responsible for doing the graphs on your homework. Just find the calculus part. And I just wanted to do the graphing parts because the visualization, we get to do a lot of this kind of graphing of lines like this, tangent lines and secant lines. I just want you to at least be familiar with the words because the words are going to be very repetitive. They're new right now when I'm saying instantaneous rate of change, the value of the derivative, slope of the tangent line. Those all mean the same, but you just got to get used to hearing them and eventually it's going to click, but not at first. At least it didn't click at first for me. 23 and 24, I said, let's just not do those. When I wrote these in red, it was a clue to me, meaning I didn't say we had to do those for homework. I think I wrote more problems than we needed to do. I kind of like 25 better than 26. I'm so afraid to do 25 without having an answer in front of me, but I'm going to do it with you. So let's work on 25, the word problem together, because this is important to understand these word problems. Calculus word problems as opposed to algebra word problems. So a toy rocket is launched straight up, and its path will go, something like this. It goes... Here, it starts at 5 feet high, or 5 meters high, so that's pretty high, like 15 feet. It goes up, and it comes back down. So that's the path of that rocket. And if I plug a number into this function, that stands for the time in seconds, and what I get out is its height in meters. I'm going to find the instantaneous rate of change at 3 seconds. And I'll talk about what that is, but first I'm going to find the 2 points. And then I'll tell you what the points mean. The first point, I'm going to plug in 3 for t, which stands for 3 seconds, and it's going to give me the height in meters. To plug in 3 for t, I'll do -2 times 3 squared plus 30 times 3 plus 5. Why would I do this in my head? That's just being stupid. So negative 2 times 3 squared plus 30 times 3 plus 5. The first y should be 77. Negative 18 plus 95. That feels right. The second point, its x needs to be 3 plus h, and its y I'm going to do on another sheet of paper because I don't think I have enough room to do that. It's y I get by plugging 3 plus h in for each of those. So I'm going to go negative 2 times 3 plus h squared plus 30 times 3 plus h plus 5. Work on the parentheses first. 3 plus h squared is 3 plus h times 3 plus h. I do first our 3 times 3, which is 9. Outers are 3 times h, which is plus 3h. Inners are h times 3, which is plus 3h. Lasts are h times h, which is plus h squared. So this is going to be h squared plus 6h plus 9 that I'm going to write after the negative 2. So to get the y coordinate of the second point, it's going to be negative 2 times h squared plus 6h plus 9. So now let me clear all these parentheses, combine like terms. I'm going to go negative 2 times h squared is negative 2h squared. Negative 2 times 6h is negative 12h. Negative 2 times 9 is negative 18. 30 times 3 is 90. 30 times h is plus 30h. 30 times 5 is plus 1. No, the plus 5 doesn't get multiplied by 30. It's just a stray. I'm going to write the negative 2h squared first, and then negative 12h plus 30h. I just do negative 12 plus 30 and get negative 8 and get positive 18h. And then negative 18 plus 90 plus 5. Negative 18 plus 90 plus 5 gives me positive 77. So the second point, its y is negative 2h squared plus 18h plus 77. There's my 2 points. Now I'm going to analyze the points a little bit. Each point, the x coordinate is the time in seconds. The y coordinate is its height in meters. So when I do the instantaneous rate of change, it's going to be meters per second at an instant. And let me keep going here. So the instantaneous rate of change, the derivative when x is equal to 3 is the limit as h approaches 0 of negative 2h squared plus 18h plus 77 minus 77 all over h. I could do 3 plus h minus 3 and cancel the 3's, but it's not necessary. The 77's cancel in the numerator. I could factor out a common factor of a h, get the limit as h goes to 0 of negative, I'm just going to factor out an h. I'm just going to factor out an h without a sign. It's h times negative 2h plus 18 over h. Still have that limit out there. Cancel the h's, and I get the instantaneous rate of change when at 3 seconds is the limit as h approaches 0 of negative 2h plus 18, which is negative 2 times 0 plus 18. The answer is 18. So calculate the instantaneous rate of change at 3 seconds. Technically, this is without words. S prime of 3 equals 18. And in terms of units, for this fraction, the numerator is in meters. The denominator is in seconds. So it's meters per second. And that's not its average speed, that's the exact speed. Since I did the limit, it's not an average, it's an exact. And when we do speed, we call it velocity in our class because speed doesn't have a sign. When I say I'm traveling, 72 miles per hour as I'm driving to Flagstaff, there's no I'm positive 72 miles per hour when I'm going to Flagstaff and negative 72 miles per hour when I'm driving home. It's non-sign, not non-directional. In our class, when we do an instantaneous rate of change where the units are in feet, meters, some sort of miles, some sort of length dimension, and the x's are times, you get velocity or the speed or the exact speed. So at 3 seconds, that rocket, its exact speed is 18 meters per second. That's what I've calculated here in problem 25. There are more word problems, but I said for this problem section, let's just do one word problem. I did it for you. Let's just get real comfortable with doing this computation, because in the next section, we're going to relive this, but instead of having nice numbers, we're going to change the numbers that make the computations easy to the letter X or the letter T, depending on the problem. And that's going to make the computations harder, but it's going to make the answer more versatile. I could answer more questions with that answer than I can with this. So let me stop, and we'll have one more section of new material, and then we'll get to the practice test and have our first test.